Hey, welcome to Programming Rainbow. In this video, we will continue on with the series of Minesweeper in C and SDL3. This is the third video, so if you would like to follow along, you can go to github.com, Programming Rainbow, and this will be called Minesweeper C SDL3. You can clone that repository, move inside the directory, and open up with whatever editor you would like. So this is the third video. I'm going to show you real quick the code from the final one. And this will be from 10. So this is Minesweeper. We have the timer running. We have 8 mines. We can make it different sizes. All right, put it on that one. And so we can make it different sizes. This is tiny, this is tiny. This is small, medium, large, and huge. When we're on any size, we can also make it larger just by, just displaying it larger. We can also, I just want to show you what the themes look like. This is the theme. These are different themes. And so it has the Minesweeper themes and the Italian flower themes, also in monochrome. We have all the faces, when you click on something, it's surprised until you click down. And if you click on it, it resets. We also have difficulty levels. So right now it's on easy. We can put it on medium, where we get more mines, hard, and very hard. Okay. So, and we have the icon and everything else. So this is Minesweeper. And in the last two videos, we're just doing the boilerplate for opening and closing a window. But in this video, we're going to be loading sprite sheets. So in all the other videos we've done, we've always loaded an image that is just one whole image for each thing we're going to display. This time we're actually going to load a sprite sheet. So it's like multiple images in one. And we're going to use a rectangle to choose which part of that image we're going to display. So I'm just going to show you the example. If I was displaying the face, I only want to display one face at a time, but I'm loading this one image that has all the faces. There's 3 different, each one of these rows is one theme. So there's 3 different themes, but the face can be different faces. It can be an up face, press down face, like the I don't know face, the happy face, and the sad face. So we only ever want to display one of these at a time. So what we do is we load the entire image as just one image. So we hold it as a texture, but we generate rectangles, source rectangles. So this image is 130 by 78. So 130 divided by 5 is 26. Let's call it 26 by 26. So if this is 26 by 26, our source rectangle would be 0, 0 for the X and Y for this guy up here. And then the width would be 26 and the height would be 26. And if I use that as my source rectangle, that would display this one right here. If instead I change my source rectangle to be, X would be 26 now and Y would be 0. And then our width is also 26 and our height, I would get this one right here. And so on and so forth. And I can go through all of them. So down here, this one would be X would be 0, Y would be double 26, which is 52, and our width and our height would be 26. So what I'm going to do is I'm going to load this as a texture, but then I'm going to generate an array of rectangles. And we can index the rectangle when we display this. We can just say the image, but then we choose one of the rectangles, and that will be our source. And our destination rectangle will be however we want to display it on the screen, its location and its width and height. So we're going to be doing this with the loader function, and we're going to be drawing the border in this video. So let me just show you what the border looks like. The border is a little bit more abstract. That's why I was showing you the faces, because what's really happening here is this right here is one image to here. This is the left side of the top of the window. This right here is the right side. And then this here is the left side of, let me show you this real quick. So I'm gonna build what's coming out of this video right here. So this is what we're looking at here. So imagine this right here is an image, and then next to it is an image, and over here is an image. So we have 3 images across the top. This one is just repeated over and over again. Then we have this little image here repeated over and over down here. We have an image here in the corner, one in the center repeated, and then one in the corner over here. So that's kind of what we're looking at. Let's see here. So this is 3 images. Right here is one image. The center is going to be an image. And then the right is going to be an image. And this is just the other theme for it, the monochrome theme for the same thing. This is the bottom right here. So we saw the bottom was, so we can see this corner right here is going to be this corner. This center bit repeated is this center bit right here. And the left bit right here is this. And these rectangles are all the same size. So visually, this is 128 divided by 8. So it's going to be 64, 32, 16. Yeah, I think it's 16 wide here. Yeah. So if we go in 16, that's the end right here where my mouse is that. And if we go to 32, that's the next image, and then past here. And part of it is transparent because it's actually being drawn off the edge and it doesn't matter to us. And then this part here, part of it is transparent, just like it was transparent in the beginning here. Part of the rest of this image is transparent, and then part of the beginning of this image is transparent. So what's going on here is the center, the left, center, and right are these 3 images, and it goes all the way out to 32. It'd be 40, 48. So right about here. Yeah, and down to here. That's a rectangle. And then there's 2 more images here, and then there's 3 here. These 3 are the bottom, same thing as the top. We have one here, we have one image here, and an image here. And these 2 are just the sides. So it's a little bit harder to understand this, but just understand these are all broken up into the exact same size rectangles. It's just part of them are transparent. So it's easier to see it with the faces because there's no transparency happening. That's why I showed the faces first. Okay. So we're going to basically, we need a member of our game that is going to be dealing with the border, drawing the border and all the stuff to deal with the border. But we're also going to make a loader function that loads these sprite sheets and creates all these recs in for us. Okay. So let's do that. So the first thing I'm going to do is going to make this border member. So I'm going to add 2 files here. That's going to be border.c and border.h. And in border.h, we'll do the include headers. And we will be adding or including the main.h. We include that into everything. So this is going to be a struct, and it's going to be holding a pointer to the render. It's going to hold an image, and it's going to hold source rectangles. It's also going to hold its rows and its columns. Now, the rows and the columns are not to do with the sprite sheet rows and columns. They're to do with the actual size of the game. So imagine we have that right now we're 9 across. So I need to repeat this center image right here 9 times across. So I have a left, 9 repeats of the center, and then the right. So I need to know how big the board is. And I also have, so these would be columns across and these are rows down. Right now it's 9 by 9, but if I make it bigger, then it's bigger. So I need to repeat this more times, right? So I need to know how big the board is. So that is going to be rows and columns. And I'm also going to hold in the size of each piece. And I'm going to call that piece height and piece width because we're actually might change the size of it. This is for the display. Like when I do this, I make it bigger and smaller. I'm actually just changing the size of the destination rectangle. So we're going to hold on to that. And there's also a left offset. And I am holding that. Now normally I could just put that in the main.h, which I will, but I also want to change the size of it again because the offset on the left, if we look here at this one, that's the offset of this. Basically, this image, this part needs to be pushed over. It's offset to the left a little bit. It looks like what, 2 pixels, 2 or 3 pixels. So it's offset 2 or 3 pixels. But if I make it larger, say I draw it twice the size, it needs to be offset by twice as many pixels. So I'm going to hold that in a variable as well. Yeah, just covering what we're going to put in here. So struct, and I'm going to call this border. So I'm going to have a pointer to the render. And then I'm going to have a pointer to the texture. I'll just call it image. And I'm also going to have a, normally I would just put a an frect like this, you know. It's normally not a pointer, but I actually want an array of recs. And I don't know how big that array may be because I've generalized the function loading. Well, I do know for this one how big it's going to be. I can, but I want to keep it kind of generic. I'm going to let the function tell me. So this is going to be an heap allocated array. This is also just a single rec, not even an array. But this one is going to be heap allocated. So I'm going to call it source recs. And the rows and the columns, this is going to be the actual rows and columns, not of the border, but of the board, because I just need to know this. And I'm going to hold on to a local variable that is the piece height and width. That's basically the size that I tell it to load, which is going to be, say, 16 wide for this, but also multiplied by the size I want to display it. What's the multiple of, So this is going to be held in a float because these are going to be used in the destination rectangle, which uses 4 floats. And the left offset. There's no top offset. The bottom is actually an offset, but that's unnecessary because we don't draw from the bottom, we draw from the top. So there's no top offset. But there is a left offset. And since this is dealing with the rectangle again, it's going to be a float. Okay, so that is basically our whole struct. And we are going to need a border new, a border free, and a border draw. So we've kind of talked about these before. This is the same as what's in the game. The new is going to be allocating the memory for border. It's going to take a pointer. It's going to take the address of the pointer to board, which will be a pointer to a pointer. The free is the same thing. We need the address of the pointer board to free it, so we can set it to null inside the function. And then we're going to have a draw, and that's going to be const. Okay, so border new. This is going to take a couple things. It's going to take the rows and the columns, so I know how big that we need to know how many times to repeat the centerpieces. It's also going to take the pointer to the render. So here's the render. And then we have that unsigned rows and unsigned columns. We also need the free, which is just void. I put a capital S on struct on accident. And we need the draw, which is also void. I'm going to make this const because it shouldn't be affecting anything. When it's just drawing, it's not changing anything about the struct. And this will just be B. So this is hold on one second. I don't know why I put these here. this okay. There was not supposed to be asterisk before the struct name or struct type. So this is our entire header file. And we do know that the C file is going to start out with including it and then allocating the memory in the heap. So it's that same function. We can just grab these. And this is a bool, so it's going to return true at the bottom. So we need to allocate, I need to dereference board one time, and I'm going to allocate the memory to it with calloc because that doesn't give me uninitialized memory. That makes sure that the memory is initialized to zeros or null. So I'm going to say that's the dereference of border equals calloc. And we need the size of struct border. And then we need to see if this was correct or not. I'm just going to grab it from game because it looks the same. It's going to be the same similar error message. Okay, so we'll say error in calloc of new border. And it's going to return false. If not, I'm going to create another variable with the dereferenced border called B. That's so I don't have to keep dereferencing border over and over again. We basically need to load this sprite sheet now. We have two different things going on here. We have an image and we have the recs. So we're going to pause this one right here and we're going to go in and I'm going to create load media, two files. So load media H and load media C. And there's just going to be one function in here. I'm going to call it load media sheet. So the one function here, and it's going to return a bool, is called load media sheet. I mean, you could make a better name for it. I just called it load media because it's in the load media thing, and it's loading a sprite sheet. So you could call it load sprite sheet or something like that as well. And we do need to render because we're going to be dealing with the texture. And we do want the address of the where we're storing this. So this is going to be affecting a pointer from inside this function, which is a pointer to a texture. So we need the address of that pointer to a texture. SDL texture. We're passing a texture into this basically, but it's going to be a null pointer to begin with, and then we are populating it. So it's going to be a pointer to a pointer, and we do need the a path to this image that we're going to be loading. So const char star, and I'll call it file path. And we need to know the width and the height of each one of these. Remember how we're going to break it up. We need to know the rectangle's width and height for each one of the rectangles that we're going to make out of this image. And it could be different. You know, the board pieces are different from the border pieces, sizes. So this is just going to be an int, and it's just int width and height. And we also need to pass in, like we're passing in the image, basically. We're passing in the address to the image. We also need to pass in the address to these recs. And we're going to heap allocate these recs with calloc because we don't know the size of the recs because we can't just bake them into the border. We could do it, but it wouldn't be as good if you ever changed your game or anything. So basically, since we don't know how many recs there's going to be, until the image is loaded, it's going to be discovered from the image. This is going to be heap allocated, and we're passing that pointer in. So again, I'm doing a pointer to those recs because I'm getting a null pointer in and I'm populating it. Okay, and I call them recs. I could have called them source recs as well. Yeah, we could just do that to keep with the same name because that's what it's going to be. So this is the function signature right here. So in our implementation, we can include this load media. I did it on the Rex, but not the images in my notes. So basically, I don't know if the address to the pointer image that you're sending in is been populated now. So if you've already loaded an image and then you run this function on the address of that same image, it's going to be a memory leak. You're going to lose the original image. It's still going to be allocated on the heap, but you're not going to have a pointer to it anymore. So what I'm going to do is I'm going to make sure that that's not populated. If it is populated, I'm going to free that image first and set it to null. Okay, so I'm just going to run a check on this because we're passing in the address to this image here, which should be null, but it might not be. And we're passing in the address to these recs here, which again should be null, but it may not be. So I'm going to check them first. I'm going to check both of these at the same time. If they're not null, I'm going to free them and set them to null. And then my function can do what it needs to do. And we haven't caught, if anything was already allocated there, it's been dealt with. So yeah. So I'm going to dereference that image one time. So basically, if this is not null, I need to use SDL, and we have the function. Where is it? So with the texture, the way we free a texture's memory is with the destroy texture, SDL destroy texture. It takes a pointer to a texture. It returns void. So destroy texture. And we still need to dereference it. We need to dereference it every time, basically, because it's a pointer to a pointer. So this is saying if it's not null, if it is something, if this pointer is pointed to something, let's destroy that memory, or it's freeing it. Let's destroy that texture, which is freeing the memory, and then we're going to set that back to null. And we'll do it as well on the Rex. Now the Rex is just something I'm going to calloc, so I don't. There's not a destroy Rex. There's just free. You just use free because that's not specifically an SDL thing. I'm going to calloc that memory. So the same thing, we got to dereference source rex, and then we need to free and we'll set it to null as well. I'm not sure why I'm getting this error. We'll check it in a second. Oh, okay. The first thing we're doing here is we're making sure that image and rex, when we dereference it one time, if that is not a null pointer. If it is, we're going to make sure it is now a null pointer and the memory is free. Image load texture, this is going to take a file name that we give it and the render, and it's going to load an image directly to a hardware accelerated texture, not a surface, which is a software thing, but a texture that your GPU can kind of understand. So basically we need the render, we need where this file is, and we're going to return a pointer to an SDL texture, which I called image in the border struct. Okay, and basically we're going to check this pointer. If it returns a null pointer, it has failed. If it returns a valid address, then it didn't fail, then it succeeded. So that's what we're going to check here. So, and we have the file path right here. So that's what we're going to use. We need to dereference image one time and then equals image load texture. Now we need the pointer to the render, which is going to be the render we've already passed in. And then we need this file, where the file is. So the image is up here. This is called borders. So that's the name of it. And it's in the images directory. So I'm going to use the local, the relative path name. Actually, I don't need that at all. It's going to be, I'm going to be sending it in when I call this function. I'm just going to use this file path right here. That's what it is. When we call this function, I'll be using that borders, but inside this function, I'm using this right here. File path. And then we need to just check this to see if this returned a valid image or not. And we've already done this before with a surface in init SDL, sorry. So I'm just going to use this to check it. So we still need to keep dereferencing it each time because it was a pointer to a pointer. And this will be error creating texture. Error loading texture. And we get the SDL get error right there. That's fine. We will return negative out of here. So I have a width and a height of each individual rectangle that I want to have, but I need the width and the height of the whole image I've just loaded and then divide that by the width and the height. So to get how many actual rectangles. So in, I'll say max rows, and this will equal the height in the from the image. So I would say image, and is it just called H, hopefully? And I'll divide it by this height up here. So if for borders, I'm not sure what the height is. Let's say it's 30 tall or something like that. So if my image was like 90 tall, I'm dividing it by 30, which is the height of each individual one. And then I would basically have 3 tall of these rectangles. Columns, same thing for columns. I'm using rows and columns because dealing with arrays. So the rows are like on the x-axis and the columns are on the x-axis and the rows are on the y-axis. So rows H height, yeah. Columns is width. And this would be width. Okay, so hopefully this works like this. Okay, we need to do this because we're dereferencing this. Okay, yeah, that should be fine. That's why in game and in border you see me dereferencing it and holding it in like a single name because you have to do this kind of stuff because this is a pointer to image, but I just need a pointer to image, so I need to keep dereferencing it over and over again. We're also going to have this issue where it's not going to, and I'll show it both ways. It's going to draw it blurry. So see how this, when I've made it bigger, it's still showing me sharp pixelation. And that's what I want it to do. But by default, SDL3 doesn't do that. SDL3, when I'm looking at this at 1,000% right now, I've made it 10 times larger than it is. And what it would do is it would blur these pixels and it would give you like a gray pixel here, and it would try to smoothen this out. And it actually, for this type of retro pixel art stuff, looks terrible. Yeah, you want the crisp pixels. Even if you make them larger, you still want it to be pixelated. You don't want this blurring, and SDL3 by default does the blurring, trying to make it look smoother, and we don't want that. So let me see if I can show you what I mean. I'm gonna do it. I'm gonna change the final project here. We'll go into this load media, and I'm gonna disable this. See, I don't know if you can see this, but it's a bit blurry. I'll try to make it bigger. And it's also not right here too. It doesn't look right, but it looks blurry. I don't like that at all. I don't want it to be rounding things and making things look blurry, and this stuff doesn't line up correctly. See, it's still sharp and correct now. And nothing looks blurry. I'm not sure if it's coming across in the video correctly. And also there was like these weird lines that shouldn't have existed between here, where like it didn't match up or something. So what's happening is by default, this scale mode, by default it's set to linear, which is giving you that kind of blurring effect. And it doesn't look nice. And also when I scale it, I get these lines in between things that shouldn't be there. But I can switch this. I can switch this to using nearest instead of linear. Let's see, scale modes right here. Right here, there's multiple modes, but if I check my implementation on my system right now, I don't think there are. Yeah, so what's installed on my system right now only has 2. So they're updating it, but it hasn't trickled down to me yet, probably. But they're saying they have a nearest, they have a linear and a pixel art version. It doesn't seem like I have this third one here, but it's fine. The nearest works fine for me for pixel sampling, and the linear, it gives you that blurring where you might actually want it if you had just a normal image and you're making it larger, but it doesn't work with this kind of pixel art kind of stuff. So I'm going to be changing that. And also, I know that in the future, SDL will have it where you can change it by default for all images you load, but it's also not implemented yet. I'm on Arch Linux, by the way. So in the future, this may be changed, but right now you have to actually set it per image you load with this function. I know there's already, I think, an implementation where it just sets it by default, it changes the default, but I don't have that on my system yet. So, and I'm guessing if it's not on Arch Linux yet, it's not on anybody's system. So we're going to change this set texture scale mode. This takes a texture and a scale mode. And I'm going to change this from linear to nearest. is what I'm going to do. And this is per image that you load. But all our images are loaded through this function, so we only need to really type it once. And this can fail as well. So yeah, I want to change the scale mode to this. So it's SDL set texture scale mode. So we need the surface, which is the dereferenced pointer to image. And we also need the scale mode, which is SDL scale mode nearest. And if this fails, we will just print an error message like this. And we'll say error setting texture scale mode. So we have these rows and columns. We have the scale mode. What we want to do now is we want to calloc how many of these. So I'm going to dereference rects. This is source rects up here, sorry. So I need to dereference it one time and I'm going to calloc it. And I'm need the size of what I'm the f rect. And this is SDL. Size of SDL f rect, but I don't want one of them. I want a bunch. So my code, I was changing the number here. I'm just going to put it here. So it's going to be this size multiplied by the max rows. I guess I could just call it rows because I'm not using rows anywhere else. And also times columns. Okay, so that's going to be the size. So whatever this size is, which is 4 floats, so that's 4 times 8, 4 bytes. 4 bytes for each float times 4, so we have 16 bytes times however many rows you say and columns that you pass in. And I'm just going to grab the error message from border. Because it's the same for the calloc that I'm going to use. Source rex Aaron calloc, and we'll just say of source rex. Okay, so that's going to give us an basically allocated space for all these rectangles. Now we need to kind of loop through and create what all these rectangles are. So we're going to say for, and we'll say int row. Okay. I used rows here, so that's fine. Int row equals 0. Y row is less than rows. Row plus plus. And for columns as well. Equals 0. Y column is less than columns. what we need to do is we need basically that we're treating this like it's a 2D array, but actually because I used calloc, a simple way to do calloc, I didn't make it complicated. I just allocated it all in one contiguous, block. So we're just going to be calculating it. We're going to be acting like it's a 2D array, but it's actually not a 2D array. So we need to know what the index is. So the index is going to be, and it's row times columns. Okay. And then plus column. Let's see if I can show that. So if here is imagine this is my 2D array, right? I have 1, 2, 3, 4, 5 columns and 3 rows. Yeah. So this is 0, 0. And if I want to index over here, this would be, was it 4, 4, 4, 2, right? This is 4, 2. This is 0, 0. This is 4, 0. This is 4, 3. This is 0, 3, right? About indexing. If we're indexing a 2D array, right? I might have this backwards. Sorry, my head is backwards. It's rows then columns. So this would be 2, 0. This would still be 0, 0, but this would 2, 0 because the row is 2 and the column is 0. Okay, if that was a 2D array, but I don't have a 2D array, I only have a 1D array. So what I need to do is, this is 4, and then this is 5, 6, 7, 8, 9, 10. You get it? So this is 0, this is 5, this is 10, and this is 14 over here. 10, 11, 12, 13, 14. Yeah, this is 14 over here, the last one. So I don't have this rows and column index. I just have a single index. So how do I calculate a single index? Well, if I say how many rows I have or how many columns I have, yeah, which is 5, I have 5 columns. If I take my row, which is 0 right now, and I multiply it by columns, I still get 0. And then I add my column to it. So my column is 0. My row is 0 times columns, which is 5, which still gives me 0. And then I'm adding 0 to it. So that's fine for here. And then when I go over here, this needs to be index number 2. So I have my row, which is 0, multiplied by how many total columns I have, which is 5. That still gives me 0. And then I add 1 to it. And we have 1, which is correct. So if I go down here, this index is 5, right? So let's do the math on this. I'm at row number 1 now, and I have my maximum columns is 5. So 1 times 5 is 5, and my column is 0, which is 5. So my answer is 5. That's correct. Over here, this should be 9. Yeah. So my row is 1 times 5 because that's my maximum columns. That gives me 5. And then I'm adding 4 to it. And that's going to give me 9. 5 plus 4 is 9. Yeah. I hope everybody understands what's happening with this. Basically, I have a 1D array, but I want to treat it as a 2D array. So I basically need to take row times total columns and then add column. And I changed it from max to just rows and columns. So this is columns. And then I add the column. So this row and column is coming from here in this loop. This columns is coming from up here. Okay, so that's going to give me the index of every spot. And we do have to dereference because rect is the address of a pointer, is a pointer to a pointer. And we need to put it in parentheses because it needs to happen first. And I think we called it source rex. Okay, so now we can index into it like this with our index. I could have called it I guess, And we can, I want to set the X. So how do we know where the X is going to be? So for here, X needs to be 0. But over here, X needs to be the fourth row, right? So if I take columns and I multiply it by width, so for each column, and I just multiply it by width. So assuming this is what is this 32, 20. Was it 24 or something? I forget what it was. 24 maybe. So assuming it's 24, I need to basically, this one's going to be 0, this is going to be 24, this will be 48. So 0, 24, 48, right? So I'm going to take my column and I'm going to multiply it by the width of each of these cells basically that we passed in here. There's a width and a height of each cell, but it does need to be a float because this is an f rect. It's a float. This x is a float here. So I do need to cast it. If you're using stricter compilers, it will complain. Times width. And the same thing for the height. It's going to be the same. Sorry, not the y is going to be rows and height, or row and height. So y is going to be a float, and it's going to be row times height. And then for the width and the height, it's just going to be width and height, but as a float. Okay, so that's setting up all our recs. So basically, we're calculated how many how many rows and heights based on our image that we loaded, the width and height, and divided by the width and the height of what we want each cell size to be. And we're just going through there and setting them. So these are just recs held in this array that we've heap allocated here. And it's not a 2D array, really, it's just a 1D array. Okay, so this is how we load our image and set our recs. So we did put the safety up here where we're making sure our image and our recs are not set before we're running this. So back into border, what we want to do is we want to set a couple things. We passed in the render, so we do want to set that. And we've passed in the rows and the columns, and we want to hold on to that because it's going to be drawn itself. So we need the rows and the columns. And now we can call this load media sheet function. And we do need to set this border piece width and height because it is basically all the pieces in the board are 16 by 16, but the top of the board is actually bigger and its border height is actually 55. So let's go in here into main H real quick and just set a couple of these. So our piece size, the size of each border piece is actually just 16 by 16. So I'm going to call that piece size. And it's just 16. But our border does have a 16 width, but it has a 55 height. So I'm just going to create another one called border height, which is separate. That's 55. And we also have this left offset. Border left. And that's just 4. That's kind of our we do need to move the pieces over just because the way that game was created in draws, even though it is 16 by 16, it's like moved over to the left but by 4 pixels. That's not my design, that's just the original design of the game. So I'm just going to put that in there. So we're going to call our function that we just created that could fail. So it's called load media sheet. Oh, we do need to add it up here as well. So we have access to that function. Now we're gonna pass the render in, which is b render. Okay. And yeah, that's right. We do need to pass the address of the image. So this is going to be b image, and that is a pointer to an image, but we need to pass in the address of that. And we need the file path. And this is where it's over here. It's images, borders. Yeah. Borders.png. And now we need the width, which is just the piece size. And we need the height, which is border height. And then we also need those rectangles, but we need the address to though, because it's a pointer to a rectangle. So that's a pointer to a rectangle, but we need the address to it. So back up here, it's going to complain. Yeah. No member name source rex. Oh, really? Oh, source rect. I changed it. It should be an S. Okay, now it's complaining that the pointer, because we need the address of this. Okay, so that runs that function. If the function fails, we're returning false. Anything that fails inside that function, it's already printing out the statement. We don't need to print it out again. We can just return false out of here. And if it's successful, we return true. So that should basically set up our board, and freeing it. Let's see. Let's work on freeing it real quick. This is again, the address of a pointer. So we're going to make sure we're going to dereference it and make sure border is a good pointer. If it is, I don't want to keep dereferencing it. So I'm just going to make this struct. And the first thing I'm going to do is see if the rex is not a null pointer. So this is going to be b source rex. So if that is actually a working pointer, I just want to free that. And then we also want to set it to null. Okay, so that deals with the recs. We also need to free the texture. So if that one, we're checking the pointer on it again, and then we'll go SDL text, destroy texture. It's called image, and then we'll set it to null. And we want to set the render to null. And then I want to free the actual border struct as well. We'll set B to null. And I want to set the original pointer that's held in the game struct to null as well. So I need to dereference border and set that to null. And I'm going to print myself out a message so I know if this function was run. Okay, so that's dealing with freeing it. Now we have this drawing. So I do need a destination rect is going to be moving around. So I'm going to create that here in the scope because we're not changing anything. This is a const. We're not changing anything in the border struct. So I'm just going to make a rectangle. So this would be an F rect. And I'll call it dest rect. And we'll say 0, 0. That'll be top left. And then we'll do the piece width. Piece width, piece height. That will give us an initial rectangle. But we do need to change the offset. So we're going to set it to negative left offset. This is going to be 4 pixels basically. Okay, with all this, we should be able to draw the top left square. So this will be, so we're going to use render. So we're using the SDL render texture. This takes a pointer to the render, pointer to the texture. It takes a source rectangle and a destination rectangle. And it's returning bool, but I'm not going to check it on this one because this happens in the game loop. So we have this render texture. And the first thing we need is a render. And then we need the texture, which is B image. And then we need a source rectangle and we need a destination rectangle. So for the source rectangle, I'm going to use my array of source rectangles, which is, and we need to send in the address to this. So this is source rex. And since this is the top left-hand corner, well, that's the very first image I have. So it's going to be 0 for my sources. If I've made that array of source rectangles, the very top left-hand picture is 0 index. And where I want it to be displayed is here, the destination one. So we'll do dest rect. And that should be enough. So this should be enough to draw an image in the top left-hand corner. But Let me just see. Did I put a scale on this? I did. So I haven't set the left offset, the piece width, and piece height yet. So I kind of skipped those. But we have this B left offset, and it's going to equal border. Is it just left is what I called it, I think. Left. But I'm going to multiply this by 2 because I want it 2 times bigger, or it'll be displayed too small on modern screens. So that's I'm scaling it by 2 basically. And the same with the piece width and piece height. And these are going to affect the destination rectangle, not the source rectangle. Piece width. So the piece width is actually piece size times 2. Piece height will be this border height times 2, which was 55. Okay, so that was that piece I was missing there. Now we do need to link this up into game, so we haven't done that yet. So game H, we need to add this. We need to include border here. And then in game, we need to, after we initialize SDL, we need to populate the border with border new. Border new, and we're passing in G, border. If it fails, we're returning false. And we're going to need to clean it up here. So if G border, we are going to call border free. And we need to send in the address. It's not B, it's G. I don't know where I typed that. Okay, B border. And we need to set this to a null. Oh, no, we don't need to set it to null. It does it itself. Okay, so this is bringing it on. It looks like we need to pass in some stuff in here. We need the render. And we need how many? I think it's 9 by 9 by default. Let me just double check. Yeah, did I set this 9 by 9 up here? Okay, we're going to add in to game H. We need the rows and the columns. And yeah, just the rows and the columns. So it knows how big it is. So in game, I'm going to move this running true because I'm going to put the other stuff with it and it needs to be above this. So I'm going to set the rows and the columns here. G rows equals 9 and G column equals 9. So now we can use rows, G columns. This should be a comma right here. We need to send in the address to this. Okay, so this is allocating a border and setting it up. So we need the address to border, we need the render, we need rows and columns. We've set them up here. And this is freeing border, making sure it is a valid pointer and then freeing it. The one more thing that we need to do is let the border draw itself. And I think have I not changed this yet? Yeah, I'm gonna create a game draw function as well, but we'll let the border draw itself. So we'll say border draw. What I'm going to do is I'm going to remove these right here. And I'm going to put them in a game draw. This will be void game draw struct game. And I'm going to forward declare this as well. Okay, that should be enough to draw that piece in the top left-hand corner. If I haven't messed anything up, and it did. So this piece is here in the top left-hand corner. It is offset correctly, and it's drawn. Now we need to draw more pieces. So the next piece I'm going to draw is the right-hand side piece. So the y is not going to change, but the x is going to change. So I'm going to say dest rect.x equals, and this one's going to be piece width times the columns plus 1 minus the left offset. So before we just had minus the left offset, but now we have to find out where's the right one. Well, the right one is going to be the number of rows that we have. Sorry, the number of columns we have. But we also need to add 1 because the columns are the number of actual squares that we have inside of the board. But the border bit is outside of the board. There's one board piece that's outside of the board. So we need to basically add 1 to it to get to where the board is. So this is going to give us the right side image. So I'm going to have the piece size times, and I just casted one of them to a float so that I get an answer as a float. So what I've done is just casted this one. So I need this columns plus 1. And I put it in parentheses because I need this to happen before this multiplication. And then we need to subtract that left offset. Okay, so this creates the x. I'm just going to paste this again right here. Yank. And we have the other side now. And I'm not quite sure if that's right. Let's look at the final one. I don't think that was displaying enough of the piece. Oh, I know what's going on. This is the first image. This one needs to be the third image, which is 2. Yeah, there we go. Okay, so what about what's in between? So I'm going to do a for loop to draw So I'm going to say for column equals 0. Column is less than B columns. And then the same with the rows. No, these are just columns. So we're going to be setting the X for each one of them. So dest rect dot X equals, so it's very much like, where is it? Like this one right here. So it's the same as that, except we're going through the columns. So instead of this one, columns plus 1, it's going to be column. And what I want to draw is the number 2 one. And we didn't change this one right here. This needs to be the second image, which is number 1. Okay, there we go. We got the top. Okay, so I can actually draw, since I'm already iterating through these, if I just change the Y one time, I can iterate through these as well. So I'm going to set the Y just in case it gets set somewhere else, which it's going to. So I'm going to, even though it's 0, I'm just going to set it because it maybe have set somewhere else to something other than 0. So I'm going to set this to 0. And then I can basically copy this. I don't even need to set the X again. Yeah, I don't. I just need to set the Y. So the Y now needs to be the kind of the same as the, what was this one right here? This, but the Y version of this. So this is going to be Y. And this is a piece height. And there is no offset on the Y. So this should be rows. Maybe I'm doing that correctly. Let's find out. Because the height of the top piece is 55, but the height of every other piece needs to be the height of the board pieces, which is width. So since I have that's 16 and this is 55, this is going to be added to it, but when it's multiplied, it needs to be width. I know it's not really the width, it's actually the height of the normal piece size. But yeah, so it's going to look funny. I know I'm talking about Y, but this is the 16 height, not the 55 height. Okay? And then instead of adding 1, I need to add the piece height, the 55. Okay. Hopefully that does something. It's still going to be the wrong image, but that's fine. Yeah. Okay. So the image that we're using is going to be the 6 image. Think. Is that right? 6? I'm going to assume for now that that's right. We may come back and change that. Yeah, it is. It is 6. Okay. So I'm going through and changing X over and over again. Y, I'm just setting it to 0 here, and the Y is here, but the X is the same. Okay, so this is looping through the top and the bottom. We never did the bottom one. So let's see here. This is the top left, top right, and then the bottom left and bottom right. They're going to be similar to this. Yeah, I skipped putting the Y. I do need the Y in each time because sometimes it's 0, sometimes it's set to something else. So I'm just going to put it in so it's never messed up. And like, even though it's here, it could be changed somewhere else. Okay, so that's top left, top right. I'm just going to duplicate these. So bottom left is going to be the same here, but the Y is going to be different. And it's going to be the same as the reason why this one's different. It's going to be similar to this right here. Top left, top right, bottom left. So this is going to be correct. It's going to be here on the Y for both. It's going to be for both of these. That should give us the bottom two corners. Okay. And the image is wrong for them. So the bottom two corners is going to be 5 and 7. So this one's going to be 5, and this one's going to be 7. The border is the hardest one here to draw because we have to figure it all out. Yeah, this looks correct. Okay. So the very last thing we need to do is draw this side here and this side here, which will be another for loop just like this one. But this one will be the rows instead of the columns. Rows. And this one's row plus plus. This one, I'm going to have two set X's, which the first one is going to be this X right up here for the left side. And then we're going to have for the right side, this one here for the X, which are the rows. Okay, so the X, and we're looping through the Y's on this one. So this Y doesn't need to be here, but it needs to be above, but we need to be calculating it. So it's going to be here, but it's going to be different. So on this one is the one that we're calculating. So it's going to be like the way we calculated this one here. So we had the piece. This one's a piece width. It's still going to be piece width for the Y. We need the row times the piece width. The rows times the piece width. And then added the height. But this is row, not rows, right? Yeah. So this one right here will be the row. Hopefully this draws. And these numbers are not right here. And this is going to be 3 and 4 for those images. Okay, yeah, there we go. So I know this one's a bit like you just have to think your way through how to draw each one, and these are kind of like hard coded in the numbers. It's just because it's the border. The border is more. There's more code going on here in the border than any other part of the project. because we need to draw each of the corners and then loop through the sides and everything else. So yeah, it's a lot. But the main thing we did was create the loading of the sprite sheet, and we're going to use that throughout the rest of the project now. So let's kind of go over what we've done here. So this sprite sheet, this is if we could just include this in any other C file, we can use this function. It takes a render, it takes a pointer to an image. That's so we can change it. It takes a file path to the image we want, the width and the height of how we're going to break up this image for the rectangles, and we're taking the address of our array of rectangles. And it did work with the text load. I didn't need to do the image load, so that was pretty nice. That's different than SDL2. But the very first thing we do is make sure that there is no image or recs already allocated on the heap. So we're going to, if they're not null, we're going to free them up and then set them back to null. Once that's happened, we're going to load our image. We're going to get our width and our height from the texture that we loaded, which is new in SDL3, without running a function on it. And we're going to set the scaling type to nearest. If it's on linear, it's not going to look right for this project. So we're going to do that, and that's passing in the texture to it. Then we're going to calloc whatever the size of all the recs we need. So we need the size of one rect, but then we're multiplying it by the rows and the columns to get us how big that array would be. Even though it's a one-dimensional array, it's the size of what that two-dimensional array would be. And now we're going through each one of them, and we're setting the rect for each of the pieces of that image that we've loaded. In game, we've added the rows and columns, and we've also added the member border. And to bring it online, we do need to pass the render to it and the rows and the columns. And to clean it up, we just need to pass in the address to it with the border free. And we did separate the game draw into its own little function here, and we're using border to draw itself, border draw, and passing in the pointer to border. This should be const. And change it up top too. So in border, we're callocing. So we're allocating the memory to border the way we always do with the address to the border that we passed in. And we're making sure it was allocated. And then we're giving ourselves, say, local B variable, so we don't have to keep dereferencing it. And we're setting the render, we're setting the rows and the columns, so it can be held internally. We're also, right now, just hard coding in, that's 2 times the size. But we have our left offset, we have our piece width and our piece height, which is the border left, the piece size, because that's 16, and the border height, because the height of the border is special for the border. And then we're going to use our load media sheet we're pass the render, we'll pass the address of the image, we pass the relative path to the image, and we have our piece size for the width and our piece height for the height. And we're passing the address of the pointer to the recs. It's the address to it. The way we free it is if we make sure that border is a valid pointer, and then we're making sure recs is valid, and we're going to free that, set it to null. If image is valid, we're going to destroy that texture and set it to null. We're going to set render to null and then free the actual allocated space for this border. And we'll set it to null, and we'll make sure that the member in game is also set to null. And we're giving ourselves a little message. This is where you kind of have to walk through each one of these here. But basically, we have this destination rect that we're going to be moving around. That's what we're doing with this destination rect. And we're drawing it, we're indexing it. You know, the very first piece is the left piece. The right top corner is the third piece in, so it's index number 2. The center one is index 1, where you can see that we're looping through it here, right here, sorry, index 1. And index 6 for the bottom. And then we're drawing our bottom right, bottom left, which is 5 and 7. And we're looping through the sides, which are 3 and 4. And you kind of just have to walk through all the math here. I'm sorry about this. This is the most verbose one, I guess, for drawing the border. But that gets us the border, and it's at scale of 2 times. We will change this later on where this is a kind of a variable and stuff that we can change when we want to. Okay, so that's kind of like how you load a sprite sheet and how you can use it in a project where you just need pieces of it. And you can do things like where you have the like the Mario. This is a sprite sheet with all the different shapes of Mario, and I'm just looping through 3 different shapes on the source rectangle, right? So you can do stuff like that. I hope that was educational or entertaining. Thanks for watching. Bye.